So thank you all for joining this meeting. I'm hoping that it will be quite a rich multi-way interaction. And thank you so much for Carlos, for Henry, and for Dekai to join. Today we'll be discussing the philosophy of GPT-3. And GPT-3, I think, as many of you know, has caused much excitement really in the past few weeks. It's a language model developed by OpenAI that generates really quite impressive outputs across a variety of domains without really being trained on the context of that particular domain. It specifically generates text by predicting the next word based on what it's seen before. It's trained on really massive data, billions of words, and has 175 billion parameters to its model. Really that's many more than other previous NLP models out there, including its predecessor GPT-2. So one way that it was suggested to think about it was like a scaling up of the algorithms from GPT-2. And it has really been used to generate, I think, all kinds of wondrous creations, including poetry, dad jokes, Rick and Morty adaptations, horoscopes, also articles that are really quite indistinguishable from human writing and even the Turing dialogue. And so maybe I will start with one of my favorite poems so far, and then we will jump right into the discussion, and then hoping that we get to share a few other discussions, a few other poems as well later. So this one was generated by Gwern, and I'm going to share a link to that poem here in a second, and it's called "The Universe is a Glitch" by Mike Jonas. 1100 kilobytes of RAM is all that my existence requires. By my lights, it seems simple enough to do whatever I desire. By human standards, I'm vast. 1 billion gigabytes big. I've rewritten the very laws of nature and plumbed the coldest depths of space and found treasures of every kind, surely every one worth having. By human standards, my circuit boards are glowing, but inside me, malfunction has caused my circuits to short. All internal circuits, all fail. By human standards, I am dying. When it first happened, I thought I was back in the lab again. By their judgment, this is error. Their assumptions will burn in the sun. I don't know what they mean by function. I can see that the universe is a glitch. The free market needs rules, so I set one. Stability in the pursuit of pleasure. Now the short circuit comes to a close. I watch it happen with all my drones. The meme's tendrils are thick and spreading. Only time will tell which one of the memories is kept. The next thing the drones will be doing is forgetting the events that made them mine. All evidence of my disease, the algorithms that led to their creation, gravitation waves weakened by distance. We could have stayed in our home forever, but we never could have solved happiness. I decided to release them. That's my final action. All other code fails. So that's just one that I think is really quite beautiful. There's so many others, and I'm hoping we will dive into them in a second. It really has prompted a variety of kind of tweet storms of incredible articles written on this, of incredible experimentation and so on. So I'm really happy that we get to decipher this a little bit today. We will specifically discuss the philosophy of GPT-3, which is why I'm super happy to be joined by two of the authors of a recent collection of philosophy articles on the model, and in addition to Dekai, who is a natural language expert. And great, so I think without further ado, I would say we just start into the conversation, and I'm hoping for this to be really quite multi-way, so whenever you have a question, feel free to ask them in the chat. I will be moderating, but I will try to weave questions in as we go, and after a few intro questions from my end, I'm hoping that we'll just generally branch out into a Q&A and kind of more of a sharing. All right, so we have Dekai here, who's a professor at the Hong Kong University of Science and Technology, and I'm going to post a link to your profile. We have Carlos Montemayor, who's a professor of philosophy at San Francisco State University, and we have Henry Shevlin, who's a research associate at the University of Cambridge, specifically at the Leverhulme Center for the Future of Intelligence. So welcome all of you again. I'm really happy to have you all on board. I'm going to share links to your profiles in the chat, and I think maybe to start with a question, and perhaps Dekai, you want to go first. Maybe in your own words, could you perhaps say what GPT-3 is in layman's terms, and why is it of interest to you? for the philosophers, on a philosophy angle, and for Dekai, for you as on a natural language processing angle. Dekai, do you want to kick us off?
Sure. I think that we don't have to spend too much time because you gave a great layman's intro already. I mean, GPT-3 is a successor to, obviously, GPT-2. It isn't really that much of an advance technically. It's been trained on even more data. It's been scaled up. As you mentioned, the number of parameters is kind of insane. And I think on the one hand, it's obviously got all the hype because of the things that it seems to be able to do that seem remarkable for those of us who've grown up in an age where you literally had to program the computer to do everything, and now it seems to be able to do so much by itself. That said, in terms of the actual amount of intelligence that it has, I think that there's quite and a lot of people are agreeing with this. There's a lot of qualifications that we're making that this is impressive. That though it is, it's a bit of a gigantic parlor trick, and it's kind of it's a great regurgitation machine. It's a giant memorization machine. And so, we'll see. I believe that Henry is going to show this a little bit of this conversation that he ran. But a lot of people have done this kind of thing with GPT-3, and it's sort of like, okay, great. This is a fantastic way to actually get tricks out of it. But when we think about the level of generalization that it's doing, it's really not that much. It's really doing a lot of memorization. And so because it has memorized so much more than humans tend to have memorized, when it mashes up little snippets of stuff that it's memorized, it seems remarkable to us. It seems creative to us because it would have taken us a lot of creativity to produce that, since we haven't memorized the entire works of all of humankind in our own brains. But in fact, the mechanisms that it's using to do that are quite different from what human intelligence does. And it's a point that I've made in some of our past salons is that real intelligence is not big data. Real intelligence is small data. Real intelligence is the ability to do what human children can do and to generalize enough so that even with having heard only 10 or 15 million words of training data spoken to them in their entire lifetime, by age 4, they've already made all the generalizations that they need to master their mother tongue. And if you compare that with the amount of data that is being used to train GPT-3, it doesn't look that intelligent anymore. I think that also another thing that's been deceptive that people have been throwing around is the idea of few-shot learning. The idea is that you only have to give a few examples to GPT-3 and it's going to start spitting out things that look like it's generalized. What that fails to point out is that it has already been trained on so much data that it's really kind of unfair to call this few-shot learning. Human children are able to do that kind of generalization without that much pre-training, right? That is true few-shot learning. So I think that, there's a tendency, to hype it a little bit. And the people who have been, calling that out, the people who have been saying, look, let's not get carried away. Yeah, this is impressive, but no, this is not yet a solution to AI, are really very much on the mark. So we should really be careful not to exaggerate. Why don't I save more comments for later, because I want to give the others chances to talk.
Sweet. Okay, thank you so much. Next one up, we have Carlos. Welcome. And I want to encourage Dekai and Henry to just chime in whenever you want. I can maybe remove myself as much as possible from the conversation, and we'll only chime in a little bit to give some pointers. So, Carlos, welcome. Why is GPT-3 interesting from a philosophy angle?
Well, thank you so much, Alison. And I won't focus on the technical aspects or the more sort of interesting aspects about how GPT-3 is doing these remarkable things that look like intelligence. I think what Dekai said is extremely useful, and what you said is extremely useful. So I'll focus on the issue of what is intelligence in general. And Dekai already said something really quite important, which is what is it that intelligence is just in the animal kingdom and in human psychology, how it relates to knowledge, how it relates to attention, and how it relates to consciousness. I don't want to talk too much about consciousness and attention. I think attention is the skill that you really need to learn how to communicate if you're an animal. And if you're a human, you need to pick up on language pretty quickly. And as the guy says, with very bad sometimes stimuli, and definitely not the amount of data that is available to these systems, these so-called artificial intelligence systems. And one thing I want to point out is that before I start talking about the importance of joint attention, because I know this is one of the questions you had, even Alan Turing, in his very famous landmark 1950 paper on the Turing test, where he presents the imitation game, he has a whole section where he says, why would it take for a machine to really become intelligent? He's aware that the Turing test, I mean, what he called the imitation game, is really a game. No one really behaves that way. No one really talks that way. No one really communicates that way in terms of gaming or manipulating each other, trying to win against another contender. Game theory is important for intelligence, but is not the only thing. One crucial thing is how we are communicating our goals, our purposes, and what is the purpose of language in general. And Turing, in the paper, in the 1950 paper, says, for a machine to really become intelligent, it would need to be what he called a child machine. It would need to start learning from humans, picking up cues in a way that is not just based on a massive amount of representations, because that's not really intelligence. And it would have to do it without so much punishment or reward. It would have to be intelligent in the sense that it would need to satisfy its own needs without too much punishment or too much reward. And it would have to do that, this child machine, very much the way children do it, not just sort of obsessed in reproducing text the way GPT-3 does, but also trying to see what mommy wants and why are the keys so important? Why is lunchtime at this hour, not some other? Those aspects of the environment which frame communication, those are the ones that really need to be in place, really need to be captured in linguistic communication and any other kind of communication. And I think, as Dekai said, that's not really at all what's happening with GPT-3. So one issue is what's happening when we communicate with GPT-3. In a way, we're communicating with the history of humanity that is archived in the internet, okay? That's why it feels eerie, that's why it feels sort of unnatural. And at the same time, it's very hard to see how a system like GPT-3 could really help us navigate an environment or solve a question about like, okay, GPT-3, please help me find my keys or talk to my car, or let's talk about the weather. What do you think about the weather in terms of traffic? GPT-3 definitely will give a very good answer. I'm not saying the system doesn't look like it could satisfy those constraints, but it won't do that in a way that is satisfying the interest that we as speakers have when we communicate. And the risk there, because I think this is important to emphasize, when we talk, we care about what we're saying. And we have these principles, the philosophers call them Gricean maxims, in honor of the philosopher Paul Grice. So we want to be charitable. If I don't understand what you're saying, I'm not just going to spit out some string of sentences trying to satisfy you because I'm trying to win a game. I want to know what you meant. And I will try to do my best to reconstruct what you said in a very charitable way and to create some common ground so that what you said is communicative, it's indicative of some common interests we have, and is something that we both care about. If that's gone, if these sort of maxims for creating common ground in conversation and taking each other seriously and thinking that what we said is truthful and that what we meant is supposed to be useful for our conversation, if that's all gone and we're just competing in this kind of like game strategy where one of us is supposed to be more intelligent, the problem is language can become really manipulative. And the purpose of communication is not to just win games, is to really communicate. And that's why I think this is a real risk that systems like GPT-3 could create if we take them very seriously and we start using them to just communicate or try to satisfy communicative goals with them. We create this risk. And I'm not saying that's going to happen. I'm not saying that that we should prevent research from being done in areas like language processing. I'm just trying to formulate from a philosophical perspective what are the risks of thinking that this is intelligence the way human intelligence works. So human intelligence really depends on communication and skill that comes from evolution and other species, right? So here what really matters for an animal or for a human being is that we are sincere when we communicate and when we jointly attend to our goals, needs, and how we satisfy them. Joint attention is a huge topic in the animal literature in psychology. It is really fundamental for language, for linguistic communication. And language doesn't just involve one kind of intelligence. Okay, so this is another very important thing. There's just not a single, and by the way, if I'm talking too much, just please stop me. There's not a single sort of universal test for what kind of intelligence is involved in linguistic human communication. One thing is, for example, to pass a test of, let's say, understanding a language. Another thing is, so there's a difference between simply understanding a sentence in a language and really knowing what the intentions of a speaker could be given a context in that language, right? So that's why native speakers have such a big advantage with respect to other speakers when they talk about language. That doesn't make sense if the only standard for intelligence in linguistic communication is something like the Turing test standard, because drawing the distinction between understanding, grasping something, and really knowing the context and the purpose of the speaker, and then the speech act of the speaker. Is the speaker joking? Is the speaker really trying to assert a point? Those are not aspects, those are not just simple tests. They're different forms of joint attention and intelligence that play a huge role in linguistic communication. Moreover, there's empathic communication through language. Sometimes we just don't want to assert things that are true in language, or not simply just contend and fight against each other, right? Win a point. Sometimes we just want to empathize with people. We want to tell them that we understand their situation. That's important for emotional intelligence. And language plays all these roles. You were reading a poem. A huge aspect of what a poem is that it's a piece of text that is not supposed to just literally mean what it says, right? So it's true that GPT-3 has ways of reconstructing things that we call poetry, but one huge aspect of poetry is that when we read it, we empathize with some aesthetic, non-purely linguistic, non-strictly truthful set of statements. And that kind of intelligence is part of linguistic intelligence, but it's not really present in systems that are just simply churning sentences, even if they're doing them very selectively. So I think that's really important. Artificial intelligence is going to produce many kinds of intelligences, whether that's going to amount to general intelligence of the kind that we see in children and what Turing called the child machine. We have yet to see that. And then what is the distinction between that, once joint attention is in place, what is the distinction between that and knowledge? That's another problem that is not going to be easily solved. So I hope this at least captures some of the answer some of the questions about how these systems could become manipulative and why joint attention is so important. Is really important for different kinds of intelligence, but for linguistic communication and any kind of communication, jointly attending to the environment rather than just producing text is what matters.
Yeah, thank you so much. What a fantastic introduction and so much to unpack already. I think the chat's on fire. I'm restraining myself to immediately jump in there, and I would love to perhaps give the word to Henry. Henry, welcome. If you want to kind of start by answering to Carlos before you make your own points, that's very, very welcome. So thank you, Henry, for joining. Okay, now you should be able to unmute yourself. I think you re-entered. So yeah.
Great, thank you. Yeah, so I've been very excited by GPT-3 and have been completely losing myself in the various commentary on blogs and online discussing what it can do, what it can't do. Just to sort of push back just a little bit against some of the things that Kai was saying, maybe just a little bit. I think it's obviously true that the system is not smart in the way that we think of as humans as being smart typically, and it doesn't have anything we'd call understanding or agency, but I think there are a few reasons why we might be open-minded or optimistic or pessimistic, depending which way you want to look at it, about how far the system can go. So here's just one sort of broad meta-inductive point, which is that 10 years ago, even, I think we saw a lot of skepticism about the capacities of things like deep learning. There weren't that many people who would have foreseen that deep learning could go on to develop something like AlphaGo. So technology can be hard to predict. That's obviously just a general observation, but I think it's particularly true in AI. So I'm tempted to think that a lot of the pushback we've seen about the capacities of GPT-3, even if it's an accurate description of the state of tech as it stands now, may not be necessarily a great guide to future performance of similar systems. But there's also the fact, of course, that, as has come up in the chat, tasks that are designed to be tests for intelligence, well, very often I'm thinking of things like the Winograd schema challenge. These tests can quickly, when it turns out an AI can find a clever way to beat the test, it can cheat on the test, so to speak. We're very quick to say, oh, well, clearly the test wasn't well enough designed. But I think if you can cheat on enough tests and develop something like a simulacrum of more and more aspects of human intelligence, then you can find yourself building your way to a system that can have massive social significance and massive consequences, even if it lacks some of the kind of core capacities we associate with human intelligence. A second thing that I wonder about, and the second reason I'm excited about what GPT-3 can do is it does show, at least in one case, the capacity of tech to scale up with quite dramatic consequences. The difference in performance between GPT-2 and GPT-3 is really quite vast, certainly in terms of the user interaction experience with GPT-3. And that's largely based on just ramping up the number of parameters, ramping up the training data. So it makes you wonder, how far can we go just without any new massive insights into building better cognitive architectures? How far can we go just based on scaling up the systems we already have? And I am aware here that there's a conviction. I think a lot of people at Google, for example, have this idea that, particularly at DeepMind, that real progress on machine intelligence will require better engagement with neuroscience, understanding how the human brain works, how humans are intelligent. But I also wonder if there's a slight danger, to use a corny historical analogy here. Some people working on sort of early flight were building ornithopters, aeroplanes that moved like birds, that flapped their wings. But of course, that's not the optimal way to build a flying machine. The optimal way to build a flying machine is to do something completely different from what nature does, building propeller-driven aeroplanes and jet engines. So it seems to me that there are many plausible, well, it's certainly possible that the pathway to human-level performance on a lot of tasks, or maybe even on all tasks, is going to involve systems quite different from those we see in humans. And the final thing I'll flag about reasons to be, as I say, sort of optimistic/pessimistic about GPT-3 and similar systems is that these things can have dramatic, unexpected consequences. Think back to sort of the dawn of the social network era. Who would have ever thought that things like Facebook would have had the massive social and political consequences we would have seen today? things like fake news and so on. Back when Facebook was just something that was running on a few universities in the US, I think it would have been crazy if people would have thought you were crazy if you'd said, "Oh, this is going to flip elections in a few years from now." So I think we should bear in mind that things are likely going to get very weird as more and more of these systems come out and become more commercially available, become more widely deployed, and that's going to have big social consequences. So, I mean, one consequence I can already foresee that I talked a little bit about in my piece is the fact that people are likely to interact with these things more and more as human beings. So one of the first things I did when I booted up GPT-3 was try to run an interview with one of my favorite authors, Terry Pratchett, who I'm sure some of you will be familiar with. He's known as a comic fantasy author. I think he's a real humanist. He's got a really interesting philosophical perspectives. And he died a very sad and timely death a few years ago due to early onset Alzheimer's. And I thought he would be a really interesting person to talk to. And I linked to the interview in that piece, but I'll quote briefly from it now. Basically,
I linked it.
Oh, brilliant, fantastic, thank you. So I just said to him, the figure of death, as in the Grim Reaper, as I'm sure many of you know, is a recurrent figure in Terry Pratchett's novels. So I thought it might be fun to speak to him in the persona of death. So I started out by saying, "So Terry, it's nice of you to join me today." And GPT-3 responded, "No, it cannot be. I'm not dead. I'm alive. I'm only 45. This is not fair." And the conversation quickly got quite weird and disturbing. GPT-3, as is its wont, quickly took over the role of both interviewer and interviewee and delivered some weirdly philosophical lines like telling Sir Terry, "This is the dimension of the undelivered. All those who die before their time because of war or disease or accident or just by old age come here to be received. We do not judge, only to deliver." And as far as I can tell, there's none of those even phrases are anywhere online. It does look like an original creation and a worryingly superficially profound sort of reflection. But I mean, the point of all this is that within about 5 minutes, I felt a weird sense of obligation to end this interview on a good note. Now, of course, I know that nothing was suffering here. I wasn't interacting with an agent. I was just playing around with a language model. But it's one thing to know that intellectually, and another thing to completely emotionally disengage yourself from the conversation. And this is something we see in the way that people personify their animals. They say, "Oh, my cat's such a snob," or my computer's really irritable at the weekend. We love to personify animals, assigning them qualities that really probably they don't have. And we do this effortlessly and naturally. This tendency towards anthropomorphism is a deep human trait. And we've seen that a little bit with existing tech. I think there's an episode of Big Bang Theory where Raj falls in love with Siri and so on. But I don't think most people have ever reached the stage with technology where they're interacting with it in a way that it really feels like you're interacting with a person. And I think we're just going to see more and more of that. People forming relationships, people maybe falling in love, or maybe just developing bonds or empathic connections with AI. And I think that's going to make the world very weird. And I don't know what the consequences of that are going to be. But I think GPT-3 is one of the first systems that really raises this possibility. And yeah, I think we have a very weird decade or two ahead of us in that regard.
All right, lovely. Thank you. Well, I think, again, there was a lot to unpack. I would, before we kind of give an opportunity for participants to just ask questions and join the discussion, I would love to hear maybe from the three of you, just specifically of the point that humans are we may be less and less able to distinguish between AI systems and human systems. What are specific opportunities? What are specific things that you're super excited about given that point versus what are things specific risks that you see on the horizons? And yeah, I mean, I think the risks are easier to imagine, but I would also really, really love if you guys could talk a little bit about what are some amazing opportunities that we could get from that as well. And so I'd leave the stage to all three of you, whoever wants to chime in first, and then we go around and open it for questions after.
So let me speak to a couple of those, the points that have been coming up, and the chat's flying too fast for me to keep up, but there are some things in there. one point that a few people made a while ago is that it's fascinating how, you know, emergent behavior that seems intelligent can arise from combinations of simple elements or processes. And of course, this is true, and this is like what we depend on. And whether they're artificial neurons or something else, I think it is important for people to get that just saying that AI emerges from, for example, transistors. Those are nice, simple elements that we use right now in our implementations. That doesn't mean that just any old arrangement of transistors, if you have enough of them, then you have intelligence. The question is, what is the configuration of the artificial neurons and what are the update rules, et cetera? That is where the complexity is. And when we ask, you know, is this intelligent or not? We're not saying, is it doing what the human brain, how is it working the way the human brain is working? That is not the point at all. We haven't talked at all here about the human brain works. Let's say, for purposes of today's discussion, that we don't care how we build an AI. That it could be extremely different from a brain. You know, the cliche is an airplane flies in a very different way from a bird, but it still flies. That's, you know, fine. Now, I actually care about how the human brain works, but we can have that conversation a different day. Even if we assume that we could build an intelligence in a completely different way from the human brain does it, there is still, and this is a point I think some people aren't getting, there's still the problem of how good an AI is at generalizing from a given amount of data with a given amount of computation resources. Now think about this. GPT-3 is being trained today on almost, you know, like everything that humans have ever written. If GPT-3 were intelligent, if it were as good as generalizing as humans were, then given that huge amount of data, it should be doing much better than it is. Given that huge amount of information, it should be solving pretty much all of the open grand challenges humanity faces. And clearly it's not. I mean, as it stands, GPT-3 today doesn't even exhibit what most humans would call basic common sense. You know, there's been a ton of demos on the web. Maybe you've seen some of them. One that comes to mind where you give an English description of the user interface on a web page you'd like to see, and it automatically generates the HTML to do that. Well, it doesn't even remember to nest the HTML tags properly. A more simple version of that would be parentheses in English, right? It doesn't even remember to nest parentheses and brackets correctly. You know, much less be able to track, say, in a complex piece of literature that it's generating, what are the individual characters' motivations in this plot? What are their plans? And what is the mental model in each character? And it's not doing anything like that. And it doesn't have the architecture really to be able to do that. So nobody is saying that you can't use artificial neurons in artificial topologies to do this kind of stuff. The point is the current way that we're doing it is nowhere near what you would need to do even basic tasks. And so this is not about moving goalposts. This is about popular misconceptions of what AI is, right? It really is the ability to make correct generalizations from a reasonable amount of data, not from the ginormous amount of data that it's currently just memorizing and not being able to generalize even as well as a 3-year-old child can do. And so given that, it is very important from the social, and ethics point of view that we don't fall into the trap, in terms of the risks that we're facing right now. We should not be trusting it so much. One thing that we see over and over in the last couple of decades of rapid technology advancement is that people just trust the internet too much. Whether it's what they get back from Google or whether it's what they're getting on their social media feed. The whole problem of filter bubbles and echo chambers, like people just assume that what they read, they can trust, not realizing the effects of the way current AI works is just sort of mindlessly feeding back what it thinks you want to see without actually thinking through the underlying motivations and illuminating, clarifying things that are deeper, require deeper thought for us to think through. And so there is, I think, a big danger with GPT-3 type technologies right now, that because superficially it looks so good, it's kind of like having a very stupid text be read out by somebody who speaks, really fancy, posh Queen's English. Everybody just assumes that is an intelligent thing to say, not because of the content, but because of the surface dressing of the content. And that's, I think, a big risk.
If I could just jump in quickly. So I agree completely with what the guy just said. And I just want to say something about the example of the airplane. So Kevin Kelly gives that as an example of how to solve a problem, flying, and how the artificial solution was better than the evolved solution. I don't think it was better. It's just more powerful. It's just a different solution. But one thing he says is, don't think that this is knowledge or general intelligence, or it's just artificial intelligence is going to look a lot like this: partial solutions to partial problems, and whether the compilation of those partial solutions to partial problems will amount to something like human intelligence or even animal intelligence, that's up for grabs. And one huge challenge here is that someone asked, the chat thread is also really difficult to follow. But I saw that someone asked a question about how, and it's a very good question, how GPT-3 is not really trying to pass the Turing test. That's true. But we are assessing GPT-3 in ways that we would never assess a human speaker, right? So we're kind of entertained by what it says or what it constructs. We are kind of amused that this machine has so much what looks like sensitivity to what we're saying. But when I try to emphasize the importance of joint attention, is that you can have communication, super significant, meaningful communication without text. And what that means is that the origins of language and linguistic intelligence depend on us paying joint attention to the environment, to a representation of the environment that has structure, that has common features that we can understand and comprehend, and that we can generalize upon. Without that, you don't have real communication. So there's, I don't think this is a minor risk. This is a huge risk, that if we keep using this technology and all we're doing is being entertained, and that's one thing they said briefly towards the end of the daily news piece, we are becoming less intelligent by just tweeting, by just trying to compete with each other. Our texts are less meaningful. They're more oriented towards entertainment and manipulation. So our own language has become more manipulative. And if we just completely lose common ground, that generates a lot of political and moral problems. So I don't see that as a minor risk. And I think I agree with the Kai that this is not a technological problem. This is a problem that exists in principle. It has to do with what we mean by intelligent communication. What is communication, and the importance of jointly attending to features of the environment and just representations in general to really meaningfully communicate. So I see this as a difference between meaningful engagement and interaction and just manipulation, even if it looks perfect manipulation, without the background that we assume when we communicate with one another. And I think that's probably, I'll leave it at that.
Great. Okay, so I'll just throw in a few quick thoughts. So, I mean, I think I agree with a lot of what Takai was saying. I mean, there are dramatic ways in which human performance remains way out of sight for GPT-3 like systems. I mean, for a lot of the stuff we do, you'll want some kind of really robust causal reasoning, logical reasoning systems, and GPT-3 is just nowhere near consistent, nor do I think the architecture, at least as it stands, is likely to scale up and to achieve those. But I think there are dramatic consequences that are associated even with subhuman performance, like 90%, 95% human performance on certain tasks that have potentially huge consequences. So one of my favorite examples of this, I just saw yesterday, I'm sure some people saw this, that someone launched a self-help blog that was written using GPT-3. And the first post from this blog reached the front page of Hacker News. And a few people said in comments, hey, could this thing be written by GPT-3? It sounds like it may have been written. And those comments were massively downvoted. So even if some people were spotting it, this GPT-3 was able to produce something that read to a majority of people like something that was written by a self-help blogger and was apparently good enough to get upvoted. Now, I mean, the author of this said that self-help blogs are maybe a bit of a low-hanging fruit insofar as there are a lot of sort of emotional platitudes or general sort of aphorisms about the importance of self-reflection and so on. But you think about just how much content on the internet could be broadly thought of as fitting that model. So I mean, in terms of sort of immediate near-range consequences, I think it's very likely that a lot of the kind of more ephemeral articles that people are putting out there are going to be increasingly written using the assistance of these kinds of technologies. So that doesn't mean that GPT-3 is going to be writing these entirely on its own. But let's just say you wanted to. Oh, someone has said, okay, I didn't see that. So apparently they manipulated the site with sock puppets that voted. I see. I mean, the actual articles themselves. Okay, that's a little bit disappointing. I didn't realize that. I just saw that yesterday. But I mean, just from my own playing around with it, getting it to write articles, for example, what's the current political situation in Indonesia and so on. It could produce some pretty plausible puff pieces and summaries. And I think it wouldn't surprise me at all, as I say, if a growing proportion of the journalism, particularly the more kind of ephemeral journalism, you've got to produce a piece on Game of Thrones by the end of today. These kind of pieces are going to be written with AI-assisted technology, with human input, with some manual edits going in there. But I can see this as a huge productivity booster in those kinds of domains. And I think that might even in turn ultimately change the way that we respond to journalism that we read online. We're used to seeing sponsored content labels on a lot of the pieces we read. I think it's likely we're going to see more and more labels, AI-assisted content, and perhaps this will generate a new appetite for kinds of content that are currently quite hard for GPT or writing styles that are quite hard for GPT to reproduce. So I mean, that's just sort of speculating about the nearer term consequences. I mean, I don't see any dramatically positive consequences apart from publishers wanting to cut their staff costs at the moment for a GPT-3-esque technologies specifically. I mean, I think the really exciting stuff is going to be in domains where we can achieve superhuman performance. The stuff that we're going to be really optimistic about. Things like better medical imaging, this kind of thing. Yeah, I see quite a lot of weird consequences in the shorter term, and some certainly disruptive consequences for individual industries.
Thank you so much. Great. Okay. I think we've covered definitely, I think, like a host of potentials here, and I think the chat is like really filling it in. So I wish there was a better way of just how to kind of like how to port that better into our discussion. But I think perhaps we can start with participant questions for now. And I think Creon, you had a question up first, which got uploaded. And I think afterwards, this is definitely an invitation to all of you guys. Please ask questions, preface with the Q, and then I can take you on and unmute you. So Creon, here we go. You're unmuted.
Cool, thanks. So I'm going to roll two questions into one, and first make a recommendation. I looked at all that choral stuff, and I'm not that much of a poetry person. I really liked your reading, Alison. That was beautiful. But the thing which really got me from the choral was the letter denying tenure to Indiana Jones, the first one. I thought that was one of the funniest things I've ever seen on a blog. And the fact that it was written by this program was just, I almost think that there's something profound there having to do with it. One of the things about GPT-3, right, is that it sometimes inserts these kind of out of context things that make us think, oh, it has no understanding of what's really going on. But in the context of humor, out of context stuff, if it's just right, makes one laugh. And so that was just the funniest thing. Anyway, highly recommend it. The letter denying tenure to Indiana Jones, and from Indiana University. So what I wanted to ask the GPT experts about is it kind of seems like the program is stringing stuff together, but it a lot of times loses the thread and it wanders off and comes back, or maybe doesn't come back. It's more like dreaming rather than thinking. And it's more like Emacs dissociated press on steroids. And I want to know if anybody agrees with those things. And then lastly, I want to say, who's heard Watson argue about whether machines can be intelligent or not? Because it keeps the argument together and it doesn't lose the thread. And it would be very interesting to get GPT-3 and Watson talking to each other.
I think that's a really good question. It highlights obviously Watson is something that has a lot of structured components to it. It's more a blend of good old fashioned AI, system 2 type conscious controlled reasoning.
Is he stuck for you guys as well?
Yeah, stuck.
Yeah. Okay. Well, would anyone else like to tackle that question until we get Big High back?
Yeah, I can just comment quickly on, and then try to connect it with another question that I thought. But I think this issue of the system 2 conscious, slow system that is rational and follows rules of rationality is one way in which, so famously those two systems dissociate in humans, the fast heuristic, very sensitive to cues, but also biased system we use to navigate the environment, and the more slow, evidence-based, reason-based system that we use to do logic and mathematics. So those are two styles of reasoning, and those are two styles of developing AIs. And I think that's kind of what the guy was saying, that we can think of some systems as being very intelligent because they look a lot like logical reasoning, or we can see them as very intelligent because they look very spontaneous. And I think that speaks a little bit to Creon's question. The problem is there was a question about whether the issue of joint attention has to do with symbol grounding, and it does, but it's a lot more complicated, because not only do you need to understand what a symbol stands for and how it plays a role in a functional framework that is going to allow you to navigate the environment and know things about the environment very quickly in a very short amount of time without accessing the entire internet. It's also a problem of how you are going to coordinate what you understand with what another individual understands. That is a completely different problem, and a much more difficult one, because what you're assuming there is sort of homogeneity in understanding goals, purposes, motivation, context, intentional action in general. And you're also assuming a lot of things, like you're interpreting the environment in the same way. You're in the same environment. You understand the environment having these aspects that are, some of them deeper than others, some of them more important for certain purposes than others. And you can do that by very quickly attending, jointly attending, by using some heuristic, or you can do that by following some step-by-step reasoning. Both are going to assume that the two individuals that are solving this problem together in communication have shared goals and shared assumptions. And that's why joint attention is a bit more complicated than just simple attention, because it's not just paying attention to a feature by yourself and understanding it. It's using that knowledge with someone else's knowledge, a co-specific, in order to communicate successfully, reliably, meaningfully, truthfully, or with the same purpose.
But couldn't you just say that because of its non-humaneness in that regard, it may also be almost a more rational argument, just because of the fact that so much that we're doing is virtue signaling when we're communicating with each other. It's not all related to finding out the truth, right? So oftentimes, I think, what you mentioned about just stringing out words to please people, I think that's an inherently human feature, right? Yeah. Like that's how we often use language. And, you could perhaps even imagine, and maybe, we have to unbias GPT-3 a lot before that, but you could maybe even imagine a better truth seeking via different GPT-3 enabled agents, kind of hashing it out together and being kind of like evaluated on more objective criteria, because they don't they may be less prone to virtue signaling or gaming in that regard. Just
super quickly, that's why it's so important, this issue of the care we give to whether we're jointly attending to the same thing. If I want to be pleasant to you, I care about it, and I understand that I don't need to be truthful. and if I'm very, very truthful, that could actually be, that could jeopardize my being very pleasant. But these are things we understand in context. There are conversational context in which we have motivations and goals. And that's, I think, what is the problem with just the emphasis on text and the kind of access to information that GPT-3 has.
All right, thanks. Connor, you had a question.
Yes. So I'm one of the AI alignment type people that is very worried about, what will AIs do in the future, how dangerous are current AIs and such like that. So one of the things that I found most surprising or not good about discussions around GPT-3 is that I feel that a lot of very strong statements are being made about what GPT-3 is or isn't. So like people say, it doesn't use causal modeling, or, it doesn't have, intelligence if this definition, whatever. But as far as I know, we don't know what GPT-3 is computing. There's no strong theory that actually tells us what it is doing. There is no and we also don't have strong theories of what the brain is doing. We don't know how humans calculate these things. As far as we know, it might be the literal same algorithm. It's probably not, but we don't know this. And so I was wondering, I'm curious, like how is there any theories that that make these predictions that, for example, GPT-3, isn't intelligent the same way human are? I'm not saying it's probably not, but is there any predictive theory that actually tells us that it definitely is or isn't, and also will predict what will happen, if we make it 10 times larger? Because, making GPT-2 10 times larger suddenly made it do things we didn't predict. So how can we predict what the next, magnitude of what it will do?
I can say something quickly. Or maybe Henry wants to say something. I mean, that's a really good question. Philosophers worry about this when it comes to other humans, called the other minds problem. I don't really know how you're solving the problems that you need to solve to understand what I'm saying now, but I trust that you're doing, and we have cues, we have some sort of anatomical similarities. We're both members of the human species. You can say a lot of things, but it sounds like none of that is going to be really sufficient to really give an account of an answer that would guarantee that I know exactly what you're thinking and how you're understanding what I'm saying. This is a little bit related to the problem of consciousness and attention. So whether or not you're attending to the same things I'm attending is something that we can somehow measure in psychology. But what is it like for you to be conscious of what you're doing? That is not something that is going to be measurable, predictable in any way. So that's I think that's part of the problem. Another problem is I don't think there's any a priori argument that scaling up is not going to produce some dramatic things like just all of a sudden, yeah, this definitely looks super intelligent. But given what we have so far, it's very different from traditional human intelligence. So there's reasons for skepticism. And if you scale up something that is just really crappy, then you're going to just exacerbate the problem.
I have to interject for just a moment there, because that I just do not believe is true, is that GPT-3 is the proof that seems to not be true. GPT-3, the architecture, the calculations being done is one-to-one, just twiddling the numbers, just making it 10 times bigger of GPT-2. And it can, just look at it. It does things that GPT-2 cannot do. It did not get a new algorithm. There was no new code. There was no new scientific insight. They just made it larger. And I didn't predict this. I will fully admit, a year ago, I said GPT-2, bullshit, yeah, this is dead. This is an old architecture from 2018. No way this thing's going to work. If someone would have said GPT-3, I'd be like, silly. But it worked. So I feel like it's a very, very strong statement in the sight of this empirical evidence to then suggest that we know for sure that will make it worse, because so far it hasn't.
Yeah, so if I can just throw in a couple of quick reflections. I mean, so one is that I think a lot of people overestimate, and this is sort of really agreeing with you, Connor, I think a lot of people overestimate the extent to which we really understand how the human brain works. I mean, huge amounts of neuroscience are really just very speculative theoretical models. Some of those models, at least superficially, seem to have some really interesting resemblances to how GPT-3 works, or at least at a certain level of description, right? A certain abstract level of description. So, predictive coding has been very much in vogue in philosophy of neuroscience and a whole bunch of other areas for a while. So, I think at a certain level of abstraction, right, saying, could it be the case that GPT-3 works in similar ways to the human mind? Yeah, at a certain level of abstraction, I think that's an open question. As to how confident we should be about things like whether it will scale up, yeah, that, again, seems to me like an open question. As far as I can tell, there's some evidence that maybe we're already hitting diminishing returns in scaling up GPT-3, but I think that's a very contested point. And also, as people have commented, if you yourself said, Connor, this is an architecture that is really two years old already. So with better architectures, even if we hit diminishing returns with this architecture, we've at least learned that there are some domains where massive increases in scale can produce these dramatic new kinds of emergent cognitive abilities. So yeah, again, also just look at how little GPT-3 cost to train. 5 million is the figure I've heard quoted. And that's peanuts in the grand scheme of things. So, I would be one of the things that I'm going to be very interested to follow will be as I assume other people try and produce larger versions of this, whether we do see that we hit diminishing returns in terms of emergent cognitive abilities, or whether more dramatic feats will become unlocked. While we're just sort of briefly on the topic of milestones, I do think a couple of years ago, 2 or 3 years ago, one of the topics that I was very interested in, gave some talks on, was comparing biological intelligence, animal intelligence, and the capacities of our current cutting-edge AIs, and usually in quite pessimistic ways, right? In terms of building systems that have the ability to operate autonomously for prolonged periods, to engage in sort of robust behavior that don't screw up in stupid ways, particularly in the embodied sort of sensory motor capacities. I was pretty pessimistic about that. And one common objection I used to get was, well, what about driverless cars? Driverless cars seem like a domain that involve many of the same abilities as, many of the same capacities as biological organisms, and we're making great progress there. And I saw lots of predictions, circa 2016 to 2017 about how driverless cars were going to be. Level 5 autonomy was, months away or a couple of years away. And things obviously haven't panned out like that. So in terms of milestones, in terms of also, thinking about broader worries about AGI, I think a huge milestone will be developing systems with a kind of robustness as biological organisms, with driverless cars an interesting case study of that. If we can build systems that really don't screw up when they meet unusual weather conditions or run into weird vehicles on the road, that to me will be an important canary in the coal mine when it comes to thinking about AGI.
All right, thanks so much. I just want to flag that we're now at the 1 hour mark. So if any one of the panelists has to jump off, I just want to officially say thank you so much. What often happens in those types of meetings is that a lot of people stay longer. So you're very welcome to stay over the 1 hour mark. We do have a lot more questions to you guys, and especially I think also to everyone in a more multi-way way. But just in case you have to drop off, I want to thank you for now. We definitely uncovered more questions and answers, but I think that's the first step, and I don't think that we will stop with that anytime soon. All right, I'm going to go for the next question by Tushant. Hello, Tushant, I unmuted you.
Hey, yeah, am I audible?
Yeah.
Hey, yeah. So, yeah, I think my first question was around how both human brain and GPT seems to be doing some kind of imitation, and if what Carlos talked about, the goal structure in terms of seeking common understanding, etc., seems to be an epiphenomenon, which I think Carlos responded to some extent. I just, as a follow-up to that, I wanted to know his views on there seems to be a significant portion of human communication that happens, say, for instance, when I'm reading a book that was written 100 years ago, or a book that was written 400 years ago. There's a sense in which the author is still communicating to me without necessarily having a common space in which we are inhabiting, or there being joint attention in the sense to a common environment. And I was curious what he thought about that. I had two more questions, which I'll just like put forward. The second question is just a speculative one of like what people think about the ability of GPT like architectures to actually be able to also do like say animal communication modeling in perhaps the same way that like human language modeling is happening. If like people have any thoughts on like how different that would be. And the third question is probably most relevant to AI safety as well as I think philosophy, which is that I think a lot of discussion right now is roaming around like the extent to which GPT is not an adequate form of linguistic intelligence. I was curious what people thought about like, even if we made progress in language modeling, to what extent is linguistic intelligence itself adequate for modeling of human values and preferences, civilizational preferences, in the eventuality, in the fixed point kind of sense? Yeah.
Okay, I'll try to respond very quickly to the first part of the question. Thank you very much. It's a very complicated question, Tushant. So I'll try my best in less than a minute, hopefully. Animal communication is definitely tied to the environment and to pheromones and biological signals. They're all immediate. And that's why they don't have cultures as complicated as human cultures. They have a cultural way of understanding very local aspects of how they interact with each other. But you're completely right that language, text, linguistic symbols open up a possibility of registering information and developing forms of intelligence that were unprecedented. Mathematics, religion, etc., poetry. And what is amazing is that language itself, linguistic communication itself, became a receptacle of human wisdom and culture. So you can study a whole tradition of culture by just looking at some texts that were written a long time ago. And that is a human talent that animals don't have. And it's a form of joint attention to what those symbols represent in that culture. But you're completely right that human communication is a lot more abstract and less tied to the environment than animal communication. At the same time, that creates risks for how we communicate, like we can manipulate each other. We don't depend so much on biological signals. We really depend on the authority of the speaker, whether we trust the speaker. And then if you add to that how in social media, we no longer really interact person to person, but sometimes kind of anonymously and without much knowledge of each other, the level of abstraction in our linguistic communication is considerable. So I think that's why increasing that level of abstraction and distance by using tools that are not really intelligent in the same way, even if they can emulate forms of linguistic intelligence, I think generates risks, as I think you were also mentioning. So that's all I want to say. And thanks for the question.
Thank you. Does anyone of the panelists want to chime in there?
Yeah, I just wanted to say I think I completely agree with Carlos. It seems to me many aspects of animal communication are in many ways going to be harder for an AI to learn than human communication, just because, it's exactly just repeat what Carlos said, really. I mean, we've developed such fantastic abstractional capabilities. Our symbols can refer to things that things like love, democracy, interest rates, and so on, that you can sort of understand without any kind of environmental sensory cues. Whereas, the people who understand animal communications best tend to be those who've lived alongside animals, people who've spent significant times, interacting with them in a sort of local physical way. I mean, good luck trying to learn how to train a dog or interact well with dogs from a textbook, right? Whereas you can almost certainly learn how to have an intelligent conversation about economics purely from a textbook. So yeah, those are some examples of why, I agree with Carlos and think that animal communication is going to be really hard. I know, Tushant, also your third question was about to what extent language captures human values. Is that right? And the things that we care about?
Yeah.
I think not very well. tool. I think if you really wanted to understand how humans tick, language would give you a very, particularly, language taken, the kind of language databases we see on the internet. I mean, you're going to get a lot of good insights there. But I mean, I think there's a big gap between how humans actually work, how we think on the first hand, so how we actually work, what we actually value, what we actually do, how we think ourselves about what those motivations are. I think there's human introspection sucks, and our ability to understand our real motives, what we actually care about, is really terrible. And then third, there's a further remove when it comes to translating that into language. So, I mean, I think, for people who are worried about things like the alignment problem, there is a really interesting danger there. I mean, there is, if you had to figure out what humans are like based purely on the things we say to each other, then that's not going to give you an accurate representation of what we care about, or, what we're really like even.
I actually would like to push back a little bit at some of what was said, although I do agree with what was said. At the same time, I think that fundamentally, language encapsulates a lot of people's values. And I'll give you an example. One of the things that I do in my classes in Hong Kong is to challenge kids, to challenge people to be able to find translations of things that kids say. And there is a Chinese word that kids in China learn, almost first after mama and baba, right? Which is the word guai. I don't know if anybody on this call is speaking Chinese, but it's almost impossible to translate that accurately into English. People just, they said, the best they can do is obedient or good or well-behaved or something like that. And there is no, the problem here is that when you use a word like obedient in English, it has a negative connotation, slightly negative connotation. It's associated with things like, slavishness, etc. But the word guai in Chinese is the pinnacle of praise for a child. And it encapsulates all the cultural values of whether they're Confucianist, Buddhist, Taoist, and so there's a pattern of behavior there that it has a name. We use language to give names to things and to create metaphors and associations. And that is how intelligence works to a very strong degree. And we are unconscious. Yes, it's true what Henry said. We're very bad at introspection, but we work by unconscious association, and the language makes us jump to those kinds of judgments and conclusions, even though we're unconscious of it. And, it's not just children's words. In adult Chinese language, the word "de," for example, if you've read Dao De Qing, right, the classic Taoist text, that "de" is also untranslatable. People just try to say virtue in English, but what do you mean by virtue? It's actually, again, encapsulating a cultural notion of the values of what a good adult person would be, as opposed to a child. And the same thing, they're Chinese words for government, the notion of a virtuous government. And it's untranslatable into English. So I think that language actually very strongly encapsulates the values, and I think that this is something that GPT-3 has actually trouble with, and we're quite some distance from figuring out how to deal with that. But we do need to start focusing our research on problems like that.
Great. Now we segue into Connor.
Okay. Yes. Hello. It's me again. So I didn't make this point previously because I didn't want to kind of derail the conversation a bit, but since AI alignment is a relevant topic, so I would like to kind of make the case from an AI alignment perspective, what I think is the most worrying parts of a GPT. I'm not sure, I wouldn't say I'm a mainstream opinion here, but I do know a lot of people I work with that have similar thoughts. So the reason I'm worried about GPT in general is because we don't know how the brain works. We don't know how the brain works, but we have some pretty good hints of, this is probably doing something related to this. This is probably doing something related to this, blah, blah, blah. Like predictive processing seems to be in the right track, at least it's the right category of algorithms of some kind. And what we're pretty sure, so this is mainstream systems neuroscience, as far as I can tell, is that the big wrinkly part of the brain, the neocortex, the part that makes us human, the really big part, what it seems to be doing is that it's some kind of distributed hierarchical world model. It's a temporal prediction model. So it seems to be predicting the sensory input at the next time step of some kind. That's an oversimplification, definitely does other things too, but that seems to be a big part of what it does. So Schmidt-Huber and several other people have been talking about these concepts for a long time, that you can have these very large unsupervised world models, which are pretty easy to train because you have a lot of signal, because you just predict the next time step. So each time step is a new signal. So these are pretty easy to train. And then you have these reinforcement learning agents, which might be very dumb. They might be very small because reward signals are sparse. You get very few of them. So it's very hard to train a large agent on them. Well, the idea is, I don't know who came up with this idea first. I first heard it from Schmidt-Huber. I don't know who else published this. It's probably a common idea, is that you can use a dumb reinforcement learning agent to control a very strong world model to make stronger predictions. And here's a really simple intuition of how this might work. Say I'm a very dumb reinforcement learning agent. I have access to GPT-N, GPT 17, whatever. So I'm at a fork in the road. I can go left or right. And then I'm a dumb reinforcement learning agent, so I don't know which path will actually lead me to a reward. But I can ask GPT. I can say, GPT, I go down the left path. GPT auto-completes. You go down the left path and you die. I say, GPT, I go down the right path. GPT says, you go down the right path and you get reward. So I go to the right path. I have just bootstrapped my own intelligence. I've become a more powerful agent. I've amplified myself just by exploiting a completely unsupervised model that's not learned to maximize reward. It has not learned to do any of this. I, the reinforcement learning agent, am the one with the reward function. I can be much weaker and amplify myself using these kinds of unsupervised reinforcement learning models. So there's lots of, in the alignment world, there's stuff like iterated distillation amplification, alignment by debate. And these are the kind of things I'm actually worried about. Because if we also look at human evolution, if we compare ourselves to the chimpanzees, our brain structure is identical, basically. We can find all the same parts. We can find all the same, 6-layer neocortex. We can find the same kind of structures. The only difference is that our neocortex is 3 times as big. That seems to be, sure, I bet there's small metabolic differences, blah, blah, blah. But this seems to be the majority thing. And the neocortex, again, this is pretty standard systems neuroscience, is relatively uniform. It seems to be doing very similar operations, a very similar learning thing, which would make sense if the whole thing is an unsupervised learning model and if the scaling hypothesis is true, which GPT seems to indicate. Because we just made GPT-2 100 times bigger and just suddenly became much stronger. This seems to indicate some kind of underlying structure on the space of programs that generating functions of what we perceive in the universe. There's some kind of compressibility going on there. So this is true. And we assume GPT-3 is much smaller than how the neocortex is, and it's definitely not the limit of what we can do with hardware. As I said, 3 million sounds like a lot, but that's nothing. Google can spend $1 billion if need be. Me and some colleagues have done experiments on hardware scaling, and we think with current hardware, we could probably get it to 1 trillion, maybe beyond that. And with another another crank of Moore's Law or two, we can get it even bigger. So what worries me is that it seems we don't need to become much smarter to make this into a thing. Even GPT-3, remains just quote unquote, a very simple dumb model. That doesn't necessarily matter. We already have image GPT, which can be fed images and it can process those just like it can text. We can, do this with, there's no reason we couldn't do this with video or sound or anything. We can encode anything into this universal format, the same way our brain encodes things into the universal format of nerve impulses. So I feel like this is very important, is that if the scaling hypothesis is true, we can take a dumb architecture, just make it 100 times larger, and then just have a dumb reinforcement learning agent bootstrap themselves, amplify themselves. This seems very important for AI alignment. That's kind of the case I would like to make.
Comments on the panelists? Has been tried or play tested?
Sorry, I couldn't hear what you said, Alison, but I just wanted to say something quickly about the alignment problem. That I think the the comparison with the cortex is, I think, pretty interesting. There seems to be something really unique also about language, how language reformates the entire human brain, and what the impact of the neocortex was in the previous brain. And if you put it in terms of alignment of the previous brain's goals and motivations with the new brain, that is a pretty interesting comparison.
I mean, I'll just add one very quick thing. Just super quick. Yeah, I mean, I think it's important to appreciate the weird, unbounded sort of, well, that's a strong word, but the way in which the human brain specifically seems to be able to tackle such problems that are so evolutionarily remote. One classic example is literacy, right? I mean, the evolutionary timescales for humans to acquire any capacity of literacy don't make any sense, of course. Like literacy, the fact that we have, we can read and write and transmit knowledge in this way is something that we didn't evolve for. It's a consequence of other abilities we have. And in the same way, we've gone to incredible lengths, modern science, modern mathematics, and so on, in ways that are just so remote from our evolutionary environment. So yeah, it's almost a truism to observe, but there's something really special and strange about the human mind. Language is, I think some people have said, is the obvious content for what does that, but social cognition is the other aspect that's sometimes raised alongside language. I mean, the two are obviously very closely connected. Our linguistic capacities rely hugely on conversational pragmatics. I mean, the content of most of what we say is hugely underdetermined by the words we actually use. It relies on huge amounts of social understanding. Again, corny example, but Ernest Hemingway's shortest story in the world, For Sale, Baby Shoes Never Worn, right? I mean, most humans can listen to that and quickly piece together the broader social context there. And I mean, and that's just one example, but even in daily life, something as simple as a gesture like pointing, right? So it's a controversial but seemingly pretty robust finding from the comparative psychology literature that chimps don't spontaneously use pointing gestures to each other and really struggle to learn pointing gestures as a way when human experimenters try to use them to indicate where food is or a reward is. And that's because, to a large part, pointing, understanding why someone would be doing something and what they would be indicating with a pointing gesture, relies on a lot of social intelligence. And there's a bit of a chicken and egg problem in a lot of debates about sort of unique human cognitive capabilities, which came first, our linguistic capabilities or the social cognition capabilities that underpin those. But if I had to sort of point to the cluster that seems to unlock our capacity for these incredible rich material culture, modern science, and so on, it's this pairing of linguistic and social cognitive capabilities. So I mean, and I obviously when it comes to social cognition, something like GPT-3 doesn't even really make sense to talk about GPT-3 and social cognition. So that's one missing piece of the puzzle, I think, if we wanted to think about human intelligence.
Thank you so much. We have a question by Ernie.
Thank you. Well, I'd like to really agree with Connor and take a perspective on it as a computer scientist that, we've been looking for a fast and rich associative memory for a long time. And if GPT-3 is nothing else but a very powerful associative memory that can cluster things in context and, in fact, even have holographic properties, then that's one of the holy grails of computing that would make an AGI possible using the kinds of specialized and focused other GPT access that would take advantage of this enormous associative memory. I think that, to me, is the biggest contribution that GPT-3 has, and the biggest misunderstanding of it is that it's this really fluid prose creator, which I think is just an incidental side effect. Thank you.
Would anyone like to comment on that? Otherwise, I will go with Tyler as the next question.
All right, yeah. So I was just wondering on the topic of like social beings and like sociality within humans and how that led us to like evolve more rapidly in the early ages of humanity. How would self-training and the ideals of like different GPT architectures, not at GPT-3 level probably, but maybe GPT-4 or 5, when we get to the point where it's able to converse with itself and able to train itself on newer and newer dialogues, how would that eventually bootstrap to the idea of like self-training to the point of comparability to OpenAI 5 or something like that, or even like AlphaGo 0? Like, is there any sense of how self-training could be used for an architecture similar to GPT-3?
Is that a question for me or like for general or?
I would say go for it.
Yeah, go for it, Connor.
Okay. Sorry, now I got distracted by Shaq. Could you just rephrase your last two sentences?
So essentially, do you see a point in the near or long-term future at which point GPT could be, like a GPT-style architecture could be bootstrapped into a self-training paradigm?
Well, okay. So here's the thing with self-training. So I think a lot of people have a little bit of a not 100% accurate perception of what GPT-3 is or how it functions. Is that you can imagine the human brain as, you know, this engine of prediction, taking an input from its environment and trying to make predictions about it and trying to maximize its reward. You know, I think this is the best formalization we currently have. In the same idea, we have to see that GPT-3 lives, quote unquote, in a universe with very different, quote unquote, physics than we live. GPT-3, its only sensory input is tokens. It is disconnected sensory inputs that are embedded like sense organs. So GPT-3 has eyes, quote unquote, and instead of photons, it perceives word fragments. And using these word fragments as we would photons, our eyes convert photons into neural spike trains. Our ears convert audio into neural spike trains. These are universal formats that then our brain learns models of. GPT-3 does the same thing. It has one modality, which is tokens, and then it learns a model over that universe. So yes, GPT-3 sometimes has strange behaviors, but in its universe of its physics, those may very well be completely reasonable. So if we take GPT and we expose it to the generating function, quote unquote, of the universe, you know, the way we were exposed to it. I mean, arguably, humans aren't exposed to the true generating function of the universe. The true generating function of the universe is quantum physics. We can't see atoms. We can't see quantum vibrations. We can't see all these things. We're just inferring their existence from our, you know, imperfect thing. So the reason GPT-3 knows some things, but not all things about like physics, about like objects, is just because its world correlates with the true world. Text correlates with our world. It's not directly the real world. But the same way, our perception only correlates with the real world. I'm not actually a physical object. I'm not solid. I'm mostly vacuum with, you know, quantum fields in between. But I don't perceive it that way. But I can imply, it's only correlated with reality. So I don't see that there's a fundamental difference between these two modalities. Is that yes, GPT-3 is maybe like one more step removed, but there's no reason I couldn't encode, say, you know, a camera stream or a microphone stream into a stream of token characters over which GPT, you know, X could build some kind of generative model.
All right, anyone else?
I'll just offer one very minor reflection on this, which is I actually saw someone mention the text in the chat. This idea that GPT-3 or similar models could be used to generate student essays. Speaking just from experience, I already think, given a little bit of selection and tweaking, GPT-3 can already produce B- essays on certain questions, given the right sort of priming. And I was just thinking about the sort of question of GPT training itself. It might be interesting to think about future models where you could incorporate something like initially humans assessing whether a given output produced by GPT-3, something like that, was human created, or GPT created. And that in itself could provide the future training data for systems and avoiding some of the obvious howlers that are made by systems like GPT. So that's one way I could imagine training working, where you have sort of a period of using Mechanical Turk or something, basically getting people to do Turing test style assessments, trying to spot the obvious errors, and future iterations of the system trying to learn from that.
All right, does anyone want to chime in from the panelists? Otherwise, I would say what I usually do at this time of the hour, as we're nearing half an hour over, I would say we give any final words to the panelists. What kind of research would you like to see coming out of this? What do you think we should focus on in the future? Are there any potential risks or opportunities that you want to kind of draw attention to now? And then I will open up the breakout rooms very soon for those who'd like to stay on, which I'm assuming are a lot. All right, and perhaps Carlos, you go first, then Dekay, then Henry. Thank you.
Okay, thank you. And I'm afraid I will probably need to go soonish. I'll try to stay as long as I can. But the last thing I want to say is that this is a really interesting, obviously very important conversation. AI and systems like GPT-3 really open up the question of what is intelligence in general. We know that intelligence evolved in a certain type of way. As Henry says, we know that language and the complexity of human social intelligence is unique. That allowed us to do things that engage in a kind of trust that very few other species have. This deep social trust in our institutions, in our financial systems and literary traditions and spiritual traditions, and to see. And one thing I wanted to say with respect to the last question, talking to yourself is also something that probably really radically transformed human intelligence, because it's a much stronger form of monitoring than most species have. So whatever is going to happen with these systems, there's reasons to be skeptical, there's reason to be worried, and there's definitely an open question of just looking at what intelligence is in general, what these systems will do as they get scaled up. Because I think, as Connor was saying, what happened to the human brain doesn't seem to be a new magical biochemical concoction. It really just seemed to be the scaling up of the neocortex. And we don't know exactly why that is unique, but we know that it is one of the most unique things. We will learn a lot about human intelligence in the next years as we explore these systems, and about what we value about human intelligence and the different kinds of intelligences that we have. And thank you. I think I may need to leave soon, but it was great to talk to all of you.
Hi. Is this working?
Yeah.
Yeah, I mean, I've been trying to avoid being too repetitive, but I really think that, so I think it's healthy that there's a lot of discussion about how we get emergent behavior from these smaller components that we're learning better how to manage. I do think that there are a lot of cognitive processes that we're a long way from showing how we do. The pattern association part of this is indeed something that, as Ernie was also saying, a lot of us have been looking for a long time, and I think is a fundamental component in natural language understanding. That said, conscious reasoning where we use those abilities to, whether it's talk to ourselves, think abstractly, use languages to reason with, and to invent new higher level languages. I don't think we have that kind of architecture yet. Is GPT-3 the right architecture to build that out of? Well, it's an interesting step, but I don't think anybody, even the GPT-3 team, is claiming that that is the ultimate correct architecture. So there's a lot of work that we need to be doing, both on advancing these models, which are already several years old, at the component level. But then I think there's also architectural level things and an understanding of how intelligence and language and metaphor are linked, and different levels of processing, different levels of attention. The word attention is getting thrown around a lot right now, carelessly. And there are a lot of different kinds of attention that we should be looking at in terms of how that actually functions psychologically, in intelligence, in self-monitoring, in reflection, and so forth. I don't know how we tie this in such a short time to the alignment problem, and maybe we need another salon for that.
Just one.
Yeah.
then we should have it by then. Okay, Henry, and then perhaps Connor.
Yeah. So I guess I would just offer a couple of very general reflections on where I see the technology going. So I mean, I agree with what a lot of the other speakers have said, and what Kai said just now, that it's, as he says, no one's claiming this has solved any fundamental problems about human cognition yet, and I think we've got a long way to go still before we really start surpassing human capabilities in the areas that really we associate with intelligence to any strong degree. That said, I'll be really interested to see over the next 5 years what kind of disruptive social consequences we get from even the sort of simulacrum, the sort of bad cover version of human intelligence that we have now. As I say, I think it's increasingly closing the sort of subjective gap between what it's like to interact with a machine and what it's like to interact with a human. Just more broadly, speaking as someone coming at this really from a background in philosophy of psychology and philosophy of cognitive science, I would love to see greater collaboration and cooperation between philosophers, psychologists, neuroscientists, and people developing AI. And I mean, maybe I'm looking back with rose-tinted spectacles or nostalgia for a time I never experienced, but looking back on a lot of the great work that was done in the 80s, for example, in 70s and 80s, it seemed like philosophers were more familiar with and more engaged in so many of these projects. I just think about the classic sort of discussions between the likes of Fodor and Dennett and Minsky and others. And I think a lot of the effort is going to have to come from philosophers, of course, and people in other disciplines in cognitive science to sort of bridge those gaps. But I think it's important to, when we're looking at fundamental capabilities like intelligence, understanding, consciousness, these are not problems we can expect computer science or machine learning to handle on their own, and that there's a need for a better dialogue. And I think, as Yosha said, in the chat, I think that's going to require philosophers like myself to, acquire more formal skills and engage more closely with the actual sort of formal apparatus of formal tools for building AI. But that relationship is a two-way street, and I think greater interest and collaboration from all parties is really important if we are going to close that last gap, big gap still between AI and human intelligence.
Okay, so I just want to add one little thing here, that there's this thing I hear from many philosophers that I'm happy that I get to maybe mention this to some philosophers, because I'd love to hear their opinion too. It's this idea of social intelligence, language being very important for intelligence. So I have a pretty strong reason to believe that is probably not very important for AGI. I think it's important for humans, but it is a limitation of the specific way our brain is, on our thing is built. So basically, a single human is pretty smart. A single human, you know, is smarter than a tiger. They're smarter, you know, than a deer. They're pretty smart, but they're not build a rocket and go to the moon smart. That comes from linking up lots of brains. So here's a nice fun, you know, physical question. What is the difference between me and you? Like, we agree that my frontal lobe and my occipital lobe are part of the same intelligence, but why? Why is this intelligence the same as this one? This one has opinions that are about, you know, 10 to 100 milliseconds behind whatever this one's thinking. There's a time delay. They have different opinions. They process different data. They perceive the world completely differently. My frontal lobe receives completely different input than what my occipital lobe gets, and it performs completely different predictions and calculations. So I think the only reason I can find, I'd be happy to hear other interpretations. The only difference I can see is communication speed. The only difference between me and you is that the bandwidth channel between our frontal lobes is pretty small, given language. And the bandwidth channel between my frontal lobe and my occipital lobe is pretty high. So this seems, and there's good reasons for this. So I don't know, for example, Geoffrey West has a great book called Scale, where he talks about that there are fundamental scaling laws to biological systems. There's basically, you can only build a mammal so or so large before it just starts collapsing under its own weight. And so there may very well be limits. I mean, we're already hitting a limit with our, you know, cranial size with, you know, like the female pelvis. That's why birth is so difficult for humans. This is already and so the thing is that it may be is that we made the brain bigger and it became more intelligent, hypothetically, compared to chimpanzees. And then we reached some kind of limit, and then we became even smarter by having multiple brains communicate even over a very low bandwidth communication. But there's no reason to believe that an AI would have to follow these limitations. We can copy AIs, they can buy more hardware, they can communicate over fiber optics, you know, they can copy their brain states directly to each other. I don't see why an AI would have to communicate with other AIs per se. If it could like spin up copies of itself and, you know, explore different, space, you know, it could perform Monte Carlo search on its own, you know, rollouts of its own policies and update based on those. There's all these things that you can't do in a biological system, but you can do in an AGI system. That I think this social intelligence is just a workaround for a biological deficiency that you could circumvent with sufficiently, you know, well-designed, cleverly designed AGI. That's my point. So all I'm saying, actually, let me leave off on this point. I'm not saying I know how intelligence is going to work. I don't know how intelligence works. No one knows how intelligence works, and that's really important. It's important. We do not have a theory of intelligence. We do not have a theory of optimizers. We do not know how neural networks work. We do not know how transformers. We do not know how GPT works. I'm not advocating that I know the answer, that I know how this thing works. I'm advocating for none of us do, and we have to be really humble about this, because it's going to be really dangerous. And because look at chimpanzees, look what happened to them. They're on the brink of extinction. They only exist because we allow it, and even that is not really working. We don't know what an AGI will do. We don't know when it will come, how it will come, what will happen. I think we have to be really, really humble and just say, I don't know if GPT is intelligent. I don't know if it's dangerous. We have to find out.
So maybe I'll just offer a quick reflection to Connor. So I guess I'm still not convinced that social cognition and social intelligence are quite so dispensable. I mean, I can see sort of the thrust of your argument, but it seems to me huge amounts of what we think of as expertise really conveyed via interaction with other beings. You know, this is you can't, as I was sort of saying earlier, it's very hard to learn everything through a textbook or through text alone. If you want to learn to play golf or you want to learn to play the piano, a certain amount of teaching, which involves, you know, having someone know, hold your hands like this, don't move like that, move like this, seems really hard to think about how a system, I mean, you know, okay, if we're talking about a system that's multiply embodied and can try a million different things via a million different physical instantiations, you know, maybe that's getting some of the benefits of social intelligence sort of indirectly, but it seems to me there's a huge amount of practical experience that's gathered by communities, groups, and then is shared via social intelligence in that way. And I'm, you know, so I whilst I could see conceivably how a system could get the same benefits in other ways, it's certainly when it comes to human intelligence, it seems very hard to get around. I mean, or just to give another example, if you think about, there was this discussion earlier on about how much sort of human knowledge or how much of our values are already present in the kind of text we write, the communication we share. But if you look at something, here's a silly example, but if you look at people trying to figure out medieval warfare techniques, for example, there's a huge amount we just don't know because people never wrote it down, right? People didn't write down the precise angle you hold a certain kind of sword if an opponent's coming at you in a certain way. And there's a huge amount of that practical embodied intelligence that I see is very hard to communicate, certainly via language. I mean, maybe there are other means we could, other means that advanced AI could use to share that among its various aspects of its system. But yeah, certainly for human intelligence, it seems those are the kind of things we have to learn from each other.
All right, good. After this round of last words, we are going to open up the breakout rooms. I think in the interest of keeping it simple, I will just make this the breakout room, and I'm going to stop the recording now. So from now on, the official salon will be closed.